Hello students, myself Mosam Pandya. Once again, we are here with measurement in industries. Our ongoing topic is strain measurement, and under the strain measurement, we will be looking into the different types of resistive strain gauge, where we will be looking into types like wire, foil type, semiconductor type strain gauges. So let us go ahead with today's topic. Before that, let us recall or recap very quickly what we did in the previous session, and that was all about resistive strain gauge, where we had bonded strain gauge, we had unbonded strain gauge, and gauge factor. In fact, for bonded and unbonded type of strain gauge, we just saw the simple configuration, and we basically focused on the derivation of gauge factor. You must remember that K is equal to 1 plus 2 mu. So let us go ahead further. So strain gauge arrangement, first of all, let us keep in our mind where here you see the strain gauge is connected, two wires or two connections are given to the Wheatstone bridge, and as you know, Wheatstone bridge is one of the device where you can measure actually resistance, but we here use Wheatstone bridge as we will be supplying here, and in balance condition the strain amplifier which is connected across two points diagonally, where it should be zero under balance condition. It means when strain gauge is connected, when it is in balance condition, when there is no stress applied, no strain measurement is there, the reading is zero, and hence it is say preloaded balance condition, and as and when the load is applied, that will unbalance the bridge, and that output will be sensed by the bridge, and then amplification and analog to digital converter and memory. So this is the entire one ideal system where strain gauge is to be used. So let us see what is strain gauge for us. So we have been talking about sensors, so many sensors. So it is one of the sensor which actually measures or sense the strain for you, like say force, pressure, tension, weight, and that will convert into electrical quantity which you can measure. So this is basically a passive type of electrical strain gauge. Passive means it needs a supply, it is not a self-generating type of, and strain varies point to point, and basically they are made as much as possible. Like we will see the comparison and scale with which it is being made, and you here see the length will be approximately 5 mm, and it is used for very small measurement, approximately 1 micrometer. Like say if you are standing on a cement beam, and some more or 2 or 3 more people are walking through a cement beam, so probably we are not able to understand is there any bending is there or not, because it is actually beyond our sensation. So if 1 micrometer, like 10 raised to minus 6 meter variation is there, it will be sensed by the strain gauge, and very sensitive material we are using within the elastic limit of the material, and the unit is microstrain, where change in length micrometer per unit meter of the length. This is a very standard terms in case of strain gauge when we talk about, and the microstrain will be the unit. So basically what are the types? Let us see. That is mechanical type of strain gauge. Basically levers and gears will be utilized to reflect the change in the length or displacement due to application of the stress and strain. Another is optical, where magnification from the mirror or prism you can use, and the third is electrical, where we will be sensing the change in resistance or inductance or capacitance, and ultimately we will calibrate our meters in terms of microstrain So our focus will be basically on electrical type of strain gauge, where we will go for some resistive kind of strain gauge. So how does it look? First of all, you see, this is all theory, and here I am teaching you online, so you should know how does it look like. We must see that. So see here I'm showing you one diagram, and probably if you remember in our offline classes in semester 4, I had shown one small arrangement on paper where we established one thread in grid like condition, and we got two ends. So here you see the picture, and I'm showing you another. Actually the scale you can imagine, like you see the scale of the actual strain gauge. Basically this is one of the foil type of strain gauge that we'll see ahead. So this picture is larger picture, and this is the very small one. This is actual. So this is quite magnified. And one more thing is, this was actually established, or this was actually first time fabricated during some 1938, 1943. Probably in India we were struggling for our independence, and the scientists in Europe they were doing this kind of innovations. And now the second picture you see here, that is actually we are utilizing. So the quantum, the scale of the strain gauge is very small. So please keep in mind this is a very meticulous small kind of sensor, and can be adjusted anywhere within a very small space. So let us see some material which we know. We should know. So basically nichrome and copper, chromium, these are the very popular material which are having quite good elasticity, very good sensation, very good response to the resistivity, linear resistance. So these are the some material and combinations, and nichrome, constant and nickel platinum combinations, and isoelastic combination where nickel, chromium and molybdenum we are using here. So our study will be focused today on bonded type and unbonded type of strain gauge, which are actually subtypes of wire wound type strain gauge. Basically there are three types of electrical means resistive strain gauge. That one is bonded strain gauge that we had already started. Another will be unbonded, and then after wire wound type there will be metal foil type of strain gauge, and third one will be the semiconductor type of strain gauge, where we will be using the concept of piezoelectricity. Now let us look at the word bonded. Bonded means something is fixed on some platform. So here you see two diagrams which you displayed on the screen, where force is applied and structure under it can be a beam, it can be the platform for a swimming pool, where or the platform of a very high altitude high rise story building, where we have to measure what are the impact of the high pressure wind and how much it can withstand against the such kind of pressures. And as I have shown you, they are very small in structure. So basically this is what we have. A very small grid of wire is formatted and two ends are taken out, but here the grid is fixed with the adhesive on some platform, and then that felt means material from textile fiber made is overlapped, and entire strain gauge is made. So let us see how actually layer by layer the strain gauge is formatted. We are talking about wire wound bonded type of strain gauge. Wire wound bonded type of strain gauge. So once again our that popular and resistance to be measured across the two outcoming ends. So this is the platform or surface on which we will be putting our strain gauge. Then this is the another layer, or you can cement adhesive. Then another platform, and this is the grid, wire grid. So let us see what are these locations. So here you see specimen surface, or it's like a beam under observation. That substrate you can see here. Then adhesive cement, that in pink color I have shown, and the felt means it's a textile material that is produced by the condensing or pressing the fibers together, and wire grid, which is shown with the red color here. Let us go a little bit ahead. The bonded strain gauge, there are certain facts that you should remember, or it will be required actually when you actually write down the theory, or you go for some MCQ kind of question. So it's a grid of fine resistance wire. The diameter is very small, like diameter of the wire 25 micrometer or less, and size 3 mm by 3 mm. Now you can imagine what should be the size of the actual sensor, which can be actually fixed on the on your nail also. The resistance value will be varying from 120 to 1000 ohms for the calibration, and excitation voltage, as it is a usual range of 5 to 10 volt DC that we are using with the Whiston bridge. Okay, so we will keep it up to this point today, and we will meet in the next session. So see you till then. Keep watching the videos and keep revising. If you have any doubt, please write down on this email. Thank you so much.